Hello, everybody, and welcome to our first webinar of 2025. My name's David Gray. I'm Head of Marketing here at Extherm by Eaton. Great to have you with us here today. The webinar is scheduled for our EMEA and APAC audience, but if you're not in those regions, maybe you're up at night. So thank you for your commitment today. So our aim today is to present a broad set of technologies around hardwired versus wireless sensors. Some of the technologies might appear familiar. This is purely to offer varying approaches and capabilities and not to critique any particular brand. So grab a coffee, sit back, enjoy the content. We've got two experienced electrical sector experts on hand. We've got John Hope, our CTO, joined by Tulsi Patel. They'll guide us through the sensor selection, hardwired versus wireless options. So without further delay, I'm going to pass you over to our host for the session and see you at the end for the Q&A. Welcome, John and Tulsi, over to you.
Yeah, thank you for that, David. That was great. So good morning, good afternoon, and good evening, everyone. And I welcome you all to the first webinar session for the year 2025. I appreciate and thank you for the time that you've all taken out from your busy schedules to join us here today. In this webinar titled Continuous Thermal Monitoring with Hardwired or Wireless Sensors, we will explore the different CTM technologies that are available in the market. We will look into their pros and cons, and we will also learn the importance of selecting the correct sensor technology and how this decision impacts the operational efficiency of the CTM system as a whole. My name is Tulsi Patel, and I look after the technical operations and customer support at Exeter. I also work under John Hope, who is our Chief Technology Officer and my mentor for the past 7 years. John has a wealth of experience and knowledge in the field of CTM and engineering spanning well over 20 years, and his expertise in this field is extremely helpful in providing the knowledge and insight for today's topic. So he has joined me here to co-present this webinar. So thank you and a very warm welcome to you, John. All right, so let's begin with the webinar. I'll give you a quick explanation of today's agenda and what we will be covering. We will start with briefly explaining what CTM is, continuous thermal monitoring, and why it is so important. We will go through the different technologies that are available in the market. We will look into the important criteria for selecting the right sensor technology. We will also dive into competitive market position and see the technology advantages. We will look into return on investment and cost of ownership consideration, and then we'll give a brief introduction into the next webinar. And at the very end, we'll open the floor to questions. So let's start by giving you all a quick introduction of what continuous thermal monitoring is and why is it so important. Continuous thermal monitoring is a process of continuously tracking the temperature of electrical equipment by utilizing thermal sensors which are strategically placed on electrical components. By collecting and analyzing temperature data, CTM helps predict potential failures, it informs predictive maintenance, and it improves the overall equipment reliability. So, continuous thermal monitoring is a very critical technology with far-reaching applications spanning across numerous industries, for example, manufacturing to oil and gas, data center, utilities, and many, many more. Its ability to enhance safety, improve efficiency, and prevent costly downtime makes it an invaluable tool for organizations seeking to optimize their operations. Looking into the current market insights, we have narrowed down some of the important key drivers, restraints, and requisites and challenges for CTM market. So, talking of the key drivers, as industries prioritize predictive maintenance to enhance operational efficiency, reduce downtime, the demand for CTM is set to surge. The next point is a no-brainer, and as we all know, it is a game changer for the market. And the CTM market is witnessing a huge growth due to the rising adoption of IoT and AI technologies, While IoT facilitates the integration of temperature sensors with interconnected networks and leveraging AI-powered analytics along with it, CTM systems can interpret large data sets generated by IoT devices to predict anomalies and optimize operational performance. The convergence of IoT and AI enhances the accuracy and efficiency of the CTM system. It reduces human intervention and minimizes the risk of errors. And in addition to this, we have the growth and demand in industrial automation systems. It is a key driver because the market requires an enhanced monitoring systems which are needed to optimize operational performance and safety. Lastly, we have automated power grids and smart transformers, which utilize the CTM technology to improve reliability and efficiency of the power delivered. So, well, with the growth of the CTM market, there are, however, some few restraints. For example, the high initial cost that is involved with the advanced monitoring system and the level of technical complexities in integrating these systems into existing infrastructure. But looking on the bright side, the market has also opened doors to a whole lot of opportunities and requisites. So the increase in adoption of smart grids presents a significant opportunity for CTM technology because government worldwide have now started to invest in smart grid infrastructure and integrate renewable energy sources. So the need for precise and reliable thermal monitoring of these components is becoming more critical. Secondly, the rising adoption of data centers. And with the exponential growth of digitalization, data centers have become even more critical, hosting vast amount of sensitive hardwares, for example, storage systems, network power equipment. They require precise thermal management to ensure optimal performance, reliability, and energy efficiency. Well, these benefits do come with some challenges, cybersecurity risk being the main one. So as IoT, AI, and cloud-based platforms increase, CTM systems often rely on interconnected network to collect, transmit, and analyze temperature data. While this enhances the operational efficiency, it also exposes this system to potential cyber threats, which, if not well managed, can have a very devastating impact. Second, we have connectivity and communication issues. This can result into loss of vital information and add to system downtime and its associated cost. Secondly, achieving long-term reliability of CTM system is necessary, but it can also be a challenge, especially if you consider critical infrastructure protection. Lastly, the sensor maintenance can add to OPEX cost over the lifespan of the switchgear, making the technology expensive on its own. So this discussion on the whole forms the basis for today's webinar topic as to why it is important to choose the right sensor technology. Well, this now leads us to go a little deeper and explore the technologies that are available in the market today and how they work. So as you can see, and probably you would be able to identify a few technologies, we've got the energy harvesting type sensors, the powered infrared sensors, the surface acoustic wave, the SAW technology sensors, RFID types. We've got fiber optics, and then we've got the non-powered, non-contact delta T exotherm sensors. Well, this now brings us to our first poll question. So the question is, what sensor technologies are you using to perform continuous thermal monitoring? Is it wired? Is it wireless or none? Okay, so here we have the results. Now this looks really good and promising. So 53% people have said wired, 27% say wireless, and 20% say none. So this is pretty good. Yeah, so moving on, let's look into the different technologies we saw on the previous slide and how they work. We've got the busbar energy harvesting sensor. So this is a small sensor and it is self-powered by the magnetic field of the powered circuit. It is secured to the connection with a loop and is in direct contact with a measured point. The temperature data is then sent via Zigbee wireless communication, which is an open source protocol to mobile phones and other devices. The sensor itself is wireless and battery free. Next, we have the surface acoustic wave technology sensors. The sensor is small, it is self-powered by the piezo effect. The temperature reading is generated via piezo element change, and they're directly mounted onto the measurement location by bolt mounting onto an existing asset bolt. So radio frequency signals are then used between monitoring units and sensors to transmit and determine the temperature. The sensor is wireless for small distance up to the antenna, which are then hardwired. And also the number of sensors are limited to number of frequencies, and a temperature jump due to an interface introduction can cause false alarms. Next, we have the RFID sensors. These sensors are small and they are self-powered by UHF, ultra high frequency, and they have a built-in temperature sensor, and they're directly mounted in contact onto the measurement location. It allows for wireless transmission of temperature data over a short distance, and this can easily be interfered with. Next, we have the fiber optic sensors. They are thermal non-powered sensors, and they calculate temperature via a wavelength. It is a contact type solution, and fiber degradation due to vibration and thermal stress over time can cause the fiber to become brittle and crack. Next, we have the exotherm hardwired sensors. They are small, hardwired, non-powered, non-contact, and they give the delta T temperature reading directly. They are maintenance-free and they have a lifetime warranty on them. So with all these various technologies that are available in the market, choosing the right sensor can be very, very difficult. So while CTM is responsible for accurately detecting and reporting temperature changes, choosing the wrong sensor can lead to inaccurate readings, missed early warnings, and ultimately a compromised system that fails to deliver on its promise. Think of the sensor as a frontline defense. It is responsible for accurately detecting and reporting temperature changes. If the sensor itself is flawed or it is ill-suited for the application, the entire system crumbles and it downgrades the operational efficiency. This particular slide here will highlight some of the factors that play a very important role in sensor selection. We have connectivity and communication as one of the main ones. Think about how the sensor will connect to the CTM system. Consider factors such as communication protocols, wiring, power requirement, and the ease of integration into existing infrastructure. Next, we have data protection and cybersecurity. Consider important points such as the data transmission protocol, and are they really secure from cyber attacks and security threats? Next, we have reliability. Consider aspects such as recalibration, the maintenance requirements, and its associated cost going forward. And also the degradation in performance and accuracy over time can compromise the reliability of the whole CTM system. We have installation and mounting requirements. Consider factors such as medium voltage clearance creep edge distances and the intrusive method of installation that can cause potential arc paths and can add future failure points into the system. Look into battery and power requirement. Consider long-term cost of expensive shutdowns and maintenance just to replace this battery on a periodic basis. Look into commissioning. Consider the complexity of commissioning. Some may require to be fully commissioned on site, while others can be done ahead of time in the factory, which can have some cost and time saving benefits. So, all in all, and as we state, the investment in selecting the right thermal sensors will pay dividends over time. And that's why selecting the right sensor is crucial and paramount to the foundation of a successful CTM system. I will now hand over to our CTO, John Hope, He will provide you with a more technical insight and importance of each of these factors and the pros and cons of the wired and wireless technology. So over to you, John.
Tulsi, thank you for that. Very good information. I hope people find it useful. But as Tulsi says, what I want to do is just go into a little bit more detail now of selection and different areas that have just been highlighted. So the first really is connectivity and communication. Yes, there are wireless sensors, there are wired sensors, but let's look at how connecting those sensors into a system. If they're wireless, well, you need antennas. And in a lot of cases, for most of the wireless sensors, you actually need multiple antennas within the panel. Transmission distance of the actual sensor on a lot of technologies is quite limited, so your sensor has to be within, in some cases, centimeters of that actual antenna. And that does beg the question, what are you actually saving? You've got a very short transmission distance. And the reason being, as we all know with our mobile phones, you're on a phone call, you get into a lift, an elevator, call them what we wish. The doors close, you lose that signal because a piece of switchgear, it's a steel box, it's an enclosure within an enclosure. So those antennas need to be close by. Some other technologies out there have a limited number of frequencies they can operate on, and each sensor must have its own dedicated transmission frequency. This can then lead to crosstalk and signals getting confused from section to section, and as we say there, it gives identification issues. The other problem with wireless in some cases can be EMF, so electromagnetic fields. Switchgear, we've got bus bars, we've got cables. High current, we've got some big EMF, EMC fields. Sometimes it can be difficult to get the signals through those. If you look at hardwired, there's no antennas. You've got no frequency or ID issues. It's fit and forget technology. And you're not having to worry about the reliability of that signal because of EMF. It's a hardwired signal. It's not susceptible to any EMF, any interference. We've then got data protection, cybersecurity. It's becoming a very big topic. It's a huge topic globally. Some wireless protocols, they are susceptible to being hacked. They have vulnerabilities. Yes, you can protect, but I think as we all see in day-to-day life, wireless, RFID, any signal that uses some form of a wireless communication is open to cybersecurity. And it's not just hacking into the sensor, it's being able to hack into the wider system and cause operational risks, security risks. Are you altering the value of a sensor? Are you telling someone there's an alarm when there isn't? So it's a false alarm. Are you also getting a non-alarm? So somebody's masking a signal. You don't know. So there are cybersecurity issues with wireless, and a lot of environments, a lot of customers, it's the first thing they say, they don't want wireless because of these issues. Hardwired, it's direct from that sensor to data card. You can't interfere it. Some may argue, well, yes, you can. You could disconnect it. You could cut the cable. But at that point, you would know you've lost the signal. So it's a go, no go. It uses a Modbus RS485. Again, yes, it's an old protocol, but it's robust. It's a very, very robust protocol. And you're getting reliability of that signal 24/7 by going hardwired. As we mentioned cybersecurity, let's just look at a few some stats for the last few years. So this is a table from 2019 to 2023. It came from the Internet Crime Complaint Centre. I'm sure David, who was on there, will mention maybe later on some the marketing area it came from as well. But what this was based on was what complaints are they physically getting out there, and these were from systems that were exposed to potential security threats, so cyber threats, data breaches, ransomware, unauthorized access to critical infrastructure. Now the blue bars we see on that graph are the number of complaints, which I think we can all see that is slowly going up from 19 to 23, starting at 467,000, steadily to 781,847,888. So it's a very steady increase, but it's an increase. Now let's look at the green column. That's the frightening one. That's the losses in US dollars and thousands. And you can see that curve over that 5-year period has actually been an exponential rise. So it's a huge rise in the losses for physically not many more complaints. So cybersecurity is a big, big issue. Hardwired sensors, there's no cybersecurity issue. And I think it also comes that more and more people are wanting systems on cloud, off premises, and again, it's opening that signal up to issues. It's no longer a luxury. Cybersecurity is a necessity. And this takes place not just in a system, but in the individual hardware devices themselves. Are they prone to hacking? Do they have firmware issues? Are there backdoors being left? Are ports open on wireless systems? So it's critical now that everybody takes cybersecurity very, very, critical, and that helps you foster the trust with your stakeholder, with your customers. It's helping to avoid those huge financial losses and also reputational damage. As an organization, as a data center owner, as a provider of systems, you don't want reputational damage that your system or your data center has been hacked because of wireless systems. And that helps you avoid those legal repercussions. So it gives you uptime, no downtime. Let's look at reliability. And again, this was a point that Tulsi raised early on in the webinar. Reliability is a crucial point in sensor selection. Wireless sensors, yes, they can get humidity, you can get dust, you might get dirt on there, some contamination. It could cause a problem for the wireless signal. It can even get to a point where you're creating an arc path on maybe from a sensor or a cable, because that wireless sensor or that fiber is physically attached to a live component, which, as the last point suggests there, could give you issues with medium voltage clearance, because you've now placed an object onto a connection point where it was designed for specific clearances. You've now reduced that clearance. And longevity and maintenance-free claims of a lot of sensors out there, they are claims. There isn't the data to back up the longevity, the lifetime of these sensors. A wired sensor, especially the XSM sensor, they're maintenance free. They never need repairing. They don't need replacement, which I think we'll see on another slide is very important. And no recalibration. They're calibrated for life. We can't say the same for some wireless systems. So This means there's no future cost. There's no future risk to that end user of costs for replacing systems, replacing sensors. Let's look at installation and mounting. I think it's one of those items where everybody thinks, oh, wireless sensor, quick bolt, undo a bolt, on it goes, done, finished. And in essence, it does sound simple. But they can only be mounted onto a bare metal surface. So it has to be onto the actual copper or the aluminium, the connection point. You're loosening a bolt. Now, if this is an existing site, you're now introducing a weakness onto that joint. You're loosening a physical bolt on the connection. And sometimes you can't torque that bolt to the same level as the other 3 or 4 on that connection. So you've introduced a weak point. Even if it's a new system on site, you're reducing the torque, you're messing with an OEM's built panel. Some can have a metallic band strap that holds the sensor on, which then needs a Velcro style hook and loop tape around there as added security. Yes, it sounds simple, but that needs maintenance. Those straps, they do need maintenance. They're soft metal. They can break over time, which is why they have the hook and loop, the Velcro band as added security. Wide sensors, we're not in contact with the conductor. We're outside that minimum creepage and clearance. So we've got no issues with becoming an arc path. We can operate on insulated bus, so a heat shrink or an epoxy coated, we can operate there. A lot of other sensors can't, and if you try tightening down onto, say, an epoxy coating, well, you're going to start causing damage. We're not requiring good bolts to be loosened, which could in future create points of failure. Let's look at powering. Wireless sensors, they need some sort of power. Now, if you've got power, then you've got an amplifier built in. You've got other circuitry built into the unit there. If you have amplifiers and even a powered infrared, they will drift. They need recalibration. Wireless sensors, if they're using the signal or the energy from the actual buzz bar itself, so the magnetic field, those sensors can go to sleep. If you de-energize the board, you de-energize that piece of switchgear, the sensor will sleep because there's no power to actually make it operate. Those sensors, when you re-energize, don't always come back to life. They stay in sleep mode. If they're in sleep mode, they need replacing. So now you've got an instance where you're having to have an outage, you're having to have downtime, getting inside the gear to replace sensors. Battery power sensors, exactly the same. The battery has a finite life. It will run out of life in maybe 3 to 5 years. So again, that means you've got downtime. And that battery life is determined by the number of readings, the number of requests. So if you're making lots and lots and lots of requests, you're reducing that battery life. Again, it's that downtime, that dismantling to go and replace those batteries. A wired sensor that we provide, there's no power source, so we don't need recalibration. It's 100% uptime. You've got no batteries to replace. So again, it's uptime. It's an important topic. It's a really important item to look at. Commissioning, again, most systems say, yes, we can be commissioned in the factory. But in reality, that's only partially true. Yes, they can be commissioned to a point. With a wireless system, as we mentioned earlier, you walked into that elevator with your mobile phone, the doors closed, signal gone. Wireless is the same. While it's in the factory and the doors are off, the breakers are out, side panels are open, that wireless signal is getting round, it's operating, it's working. You can only commission fully a wireless sensor system when it's on site, with all the doors closed, with all the metalwork of the panels in place, with all the cables, all the breakers in, and the system energized. So we've got these EMF, we've got these magnetic fields. Then you can start to commission. If you find, I can't see sensors, I've not got a wireless signal, I can't pick up, you've then got to dismantle, you've got to get inside, move the antenna to a new position, and try again. So it can be a complicated commissioning problem, and that just adds cost and adds time to the project. The Exotherm wireless sensors can be fully commissioned in the factory. You know they're working in the factory before they leave, before they arrive on site. So actually the site work required is very limited. A quick check, is it operational? Yes. So that cuts down on the cost, that cuts down on those project times. A very important point to take in. Let's go into poll question number 2 now. And this really is what challenges do you face or have you faced when using your current thermal monitoring system? So we'll just give that a minute or so to run, if people wouldn't mind popping some answers in there. Okay, don't want to leave it too long. So, okay, let's end there. We've had a minute. That's really good. Let's look at the results then. So, as we said, what challenges do you or have you faced when using your current systems? Quite interestingly, 13% say connectivity or signal reliability, 16% maintenance and recalibration. Yeah, as we've just mentioned, it's a big issue. You don't want to be having to recalibrate. 32% installation or setup complexity. Yeah, that again, it is a big issue. You want it to be simple. 13% communication issues. Yeah, that can be linked with sort of that connectivity or signal reliability. And almost a quarter have said not applicable, so they're either using a system that doesn't have problems or not using. So it's really, really good information. Thank you. Right, let's go back to here. So this is just a very quick table, and I'm not going to read through this line by line and point by point. I think this presentation is shared afterwards. But what this really is looking at is a position analysis on the competition based on exotherm versus a surface acoustic wave, a fiber optic, powered IR, and an energy harvesting style sensor. So really what it's saying is, are things non-contact? It's single sensors to give delta T, them being non-powered, zero maintenance, lifetime warranty, no hardwired. And again, as I said, I'm not going to read through every one, but you can see these are the items that are so important and what the others can offer. Yes, some have got a green tick. Powered IR is still non-contact. Fiber optic, yeah, it's non-powered. It doesn't need antennas, neither does a powered IR. No retrofit issues really on powered IR, but you've then got the maintenance issues, recalibration. And as we say in the notes here, just at the top, the source system, although the sensor's wireless, the system itself isn't. So you've got to have this network of hardwired antennas, and in a single section of switchgear, you might need 3 or 4 pairs of antennas. So that's 6 to 8 antennas physically within that piece of gear just to be able to collect all those signals because of all the compartmentalized, all the steel work, all the setup of the system. So, it's very, very important looking at what can Exotherm give versus those other technologies. Let's just look through some advantages now. Exotherm is small, it's non-contact, we're non-powered, we're plastic, it's non-conductive. So we're not compromising any type testing because it's outside that minimum creepage and clearance. Doesn't require good bolts to be loosened. We're not creating an arc path. We're not in contact. It's not a fibre that's in contact with that live termination and could get contamination. It measures delta T, and that's really important. It's that globally recognised method of detecting a compromised joint. It's what thermographers have used for the past, 20, 30, however many years. So it's globally recognised, and it's a single sensor that gives you delta T. We're not needing multiple sensors. Certified lifetime calibration. The infrared sensor is non-powered, no amplifier, it's calibrated for life. It never, ever, ever needs recalibrating. We can give certified reliability, mean time to failure. At the moment, we're looking at 13,000 years. Yes, it's a crazy number, but that's based on the sensors out in the field over the last 20 plus years, and we're talking hundreds of thousands versus the returns, which I could count on one hand and still have fingers free. Exotherm, yes, it's hardwired, but we're using industry standard communications, industry standard protocols. It's not affected by magnetic fields. They've been tried and tested. It's robust, doesn't cause signal issues. Let's look at costs. So, cost savings. Well, if we look at other technologies compared to Exotherm, so let's all be fair, purchase price, they're roughly, yeah, we're not a million miles apart, roughly about the same. Installation costs, depending what technology you have, roughly the same. Could be argued a wireless is slightly less expensive, but let's just think of all the other costs involved. With Exotherm, you don't require that extra sensor to measure the ambient and give you delta T. Other technologies, it's an extra cost. Yearly maintenance. And let's multiply that by lifetime of the gear, 30 years. Exotherm, 0. Other systems, you've got replacement of sensors, calibration of sensors, replacement of straps, replacement of batteries. Again, if that equipment starts to fail and the warranty that they give only lasts for 2 to 5 years, well, if it's failed, you've got to pay for those sensors to be replaced. Exotherm's lifetime warranty. They're very reliable. So I think what you can see from the table there is other technologies over that 30-year lifetime, and this is something you've really got to look at, is the entire life, not just day one costs. You've got huge extra expense over its lifetime of calibration, sensor replacement, downtime required, battery replacement. With Exotherm, it's that day one cost that stays throughout its life. So there's a huge saving. So just to conclude, we're racing through the time here. As Tulsi mentioned earlier, a very important point is selecting the correct technology. It's a critical decision to make. It's got to be cost effective. It's got to be secure. It's got to be reliable. It's got to be scalable. So you've got to think of the whole lifetime of this. The long-term implications of selection, reliability, cybersecurity must be considered. Factors such as maintenance and your calibration, warranties, you must take all those into account. Look for that long term. It's a long-term project. It's not just a today, I've got it working, I've handed it over, not my problem anymore. And then those technical complexities in both installation and commissioning. Is it that we have to wait till it gets to site to be commissioned? Then you've got downtimes. Then you've got to move sensors, move antennas, energize it. No, still not working. So you've got to bring all this into consideration, not just loosen the bolt, sensor under the bolt, tighten it up, job's done, walk away. Must bring all these points into consideration. Let's go to question number 3. Which of the following is a priority for you when selecting a thermal sensor technology? Yeah, somebody's beat me to it there. Reliability, long-term cost savings, maintenance, cybersecurity and data protection. Well, really thanks for those that have put their input into there. So, when we look at the results from this poll, crikey, well over half of the people here have voted, so thank you so much for that. Reliability, 72% have said reliability is the key factor. Long-term cost savings, 14%, so yeah, still important. Maintenance, about 9%, and cybersecurity. So at the end of the day here, reliability wins. So the last couple of slides now, and then we can drop into question and answers. So this one really is just a very quick introduction into what the next webinar will be. Oh, my screen gone. This is going to be talking about load map and why it's important. What Exotherm offers is a simple to use piece of software called Load Map. And this was created really to calculate the warning alarm thresholds, which are suitable for circuits where you're not utilizing full load, you're operating at low loads. It's a big area that's important that Load Map will help you identify hidden issues, hidden problems well before it starts to become an issue. It can be dynamic or static, and again, we'll go into those details when we run the webinar. But this will be the next one up. So, why is Load Map important for creating those new alarm thresholds? We'll go into the Q&A session. Again, as was mentioned earlier, use the little question icon up in that top part of the bar. I see there are 11 questions already up there. So I don't know if you want to grab some, David.
Yes.
We've got one person who has had the hand up as well. I think they've got a question. He came up.
I'll just say, John, that final poll question was really striking. With the response on overwhelmingly in favour of reliability. Really keen to hear from our audience exactly why reliability is the most important thing and why in such force the votes swung in that direction. We'd love to hear over and above cost, cybersecurity and things like that. Really, really clear opinion there. We do have a whole bunch of questions, conscious of time. One of the first was around power and battery. Without power and battery, how does the sensor work?
Good question. Very good question. The exotherm sensor, if you imagine it like it's an infrared thermocouple. So the device in the actual sensor itself, the thermopile, acts very much like a thermocouple, where if you have two dissimilar metals which are joined to make that junction a thermocouple, as you heat that joint, it creates a very small electrical signal. A thermopile operates in the same way. As it detects infrared, that infrared, I suppose the best word to say is almost excites the sensor, and it creates that small electrical signal which we pick up in the data card. So because of that, there's no power supply required. It's not a current loop, doesn't need anything. You could actually connect a meter to the sensor, and if you put a hot target in front of it, you'll see that meter will actually fluctuate.
Good stuff. Thank you, John. Do wireless sensors, and maybe we'll open this up to wireless and wired sensors, capture all the data when used? It's quite a broad question, so you may have to précis that response, John.
So, do wired or wireless sensors capture all the data?
I think this is really aimed at the load map session next, where we could perhaps mention software platforms.
Yeah, it might be that we come back to that question and sort of answer it later. But I mean, yes, the sensor, the wired sensor captures all the data in terms of the sensor itself is reading the local ambient around that area. The sensor is then detecting the infrared being emitted, and then the delta between the two is the output of the sensor. Now, with a wireless sensor, it's only collecting that one piece of data and outputting one piece, so it's actual temperature. You'd need a second sensor to give you, an ambient, so we could have a delta. But maybe we can add a little bit more meat onto the bones there, as it were, when we actually answer the questions later on.
Yeah.
I think another one I've noticed there that says, does a wireless sensor capture all the data when used when the batteries die, so the battery's depleted? Well, once that battery's depleted, then the sensor's no longer working. And a lot of the ones on the market, you can't replace the battery. You have to replace the whole sensor itself.
Got it.
Now, I did notice one, Dave, and it was one. You said, are there any products suitable for indoor or outdoor gas turbines whose casing insulations are too old and the customers are not able to change the insulation due to limited budgets? If you're looking at physical casing temperature, so I presume what we mean here is the casing of the actual turbine itself. Yes, we do have sensors that can monitor there. Not something we've done a lot at. I think one thing what we'd need to look at is let's further the conversation and look at what temperatures are we looking at, what temperature range, what kind of material, what kind of distance we can be. But yes, I'm pretty sure there is something there we can do for you.
I've got another one here, John. Are there installations and industries that are better suited to wired or wireless installations for sensors? So, for example, I think the question is really centered around if you imagine data centers versus maybe the water industry, would one suit the other more?
I think it all comes back to one of the earlier poll questions of what are you looking for? Firstly, there's reliability, which obviously was the top answer. You're wanting a solution that's reliable. Why? Because you're wanting data. if we flicked over to, say, the data center market, wireless sensors in most cases, I think most data centers that we've had exposure with over the many years, almost outlaw wireless sensors because of the cybersecurity, because of the signal issues. So they want to go hardwired. Other areas, yes, I could see some industries may say, I'm not too worried about that. I can cope with a wireless sensor. It's simple, it's easier. In the first instance, yes, it might be. So I think to say suited to one industry or another, they're all suited. It's what does that end user want? What does he want out of the system? If it is a data center or banking organization, then they're not going to want cybersecurity issues. So in that case, wireless isn't always as well suited.
And a question from me, actually, John, is there a cybersecurity standard for manufacturers yet? Are we too early in the evolution of this technology, or is there? Do you know of anything?
I don't know of anything. I mean, cybersecurity, there are dozens and dozens of standards of what you should and shouldn't be able to, and every system seems to have its own. I don't actually know of one standard where all sensor manufacturers are having to adhere to. And I think that's why there's so many different technologies, you know, with SAW, with RFID, with ZigBee, they all work in their own little ways, but there's weak points. I can see that yes, there will be a standard that will come in, and people will have to work to it, or start moving more towards a wired system.
Good. Really interesting question that's just flown in. For rail networks, the customer needs to check and record temperature between the rails in desert where temperature shoots up. Can the sensors withstand vibration? I mean, I don't think we actually monitor rails, but it depends on whether it's
Well,
electric.
actually, it's quite an interesting question, because 20 years ago, when Exotherm, when we first started, one of the sides of the industry of our company, was a rail division, and actually, we did monitor the temperature of rails with an IR sensor. There's no issue. Yes, it was to look for temperature, as you say, when the heat goes up and the rails start to buckle. When we talk of vibration, yes, the IR sensor can withstand vibration. It's had a huge amount of seismic tests carried out, passed everyone with flying colours, even to a point of shock testing, and that was carried out up to a level of 50 Gs. So the sensors were actually put into an environment where they were getting a 50 G shock, and no problem, they carried on working.
Fabulous. One question I want to answer is that yes, we will distribute this as a recorded video following the event, probably next week now, given we're so close to the weekend. It'll take a little time for the guys to follow up. Here we go. Yes, final poll question, John.
Yes, I've forgotten about this one, David, sorry. So yes, the final poll really is, and it's sort of for David's benefit, really is, would you like to receive the Q&A document after this session? So all the questions that have been asked in this morning's, or well, whatever time of day we're in now, and there's another session later on this evening for sort of the Americas side of the world. If you'd like to receive the answers and all the questions, obviously they're all totally anonymous. If you vote in here, and then we can get those through to you.
And just to add to that, if something springs to mind following the webinar, please don't hesitate to reach out to your local contact, ask, or come to us via the website, or reply to the email. We'll do our best to include any questions or respond to anything.
Okay, so I think we've had 32 up to now said yes.
There's only one person that doesn't want the Q&A,
Says-
so sorry if that lands in your inbox by mistake. We can't tell who you are. Wonderful. I think that's a wrap, folks. Thanks everybody for tuning in today. Hope you enjoyed the session, and thank you, John and Tulsi, for a wonderful presentation. And we'll let you know when the next one's coming along. Do sign up. It'd be great to see you.
Yep. Thanks to everybody for attending. Thank you. Thank you.
Thanks, everyone.
Bye-bye.
Bye-bye.
Bye-bye.